Hello, everyone. Welcome back to week 2 of the live stream classes. Good to see everybody who made it in this week. Glad that you all decided to come back. First of all, before we get into what I want to talk about this week, I wanted to address a question from last week. We had a question in the live stream last week about the difference between Docker and a virtual machine. So I was a little unclear about Docker. I hadn't really heard a whole lot about Docker. So I wanted to go back and research it and find out a little bit more about Docker. So I went back and I did that and got a little bit better information. And wanted to get that for you all right here at the start of class this week. So a Docker and a VM, they're very similar insofar as they both provide isolation. But that's about where they part ways. A Docker is essentially a container at the application level. So it's taking basically a sandbox approach to how we run virtual appliances. So containers in that sort of way don't do true virtualization because they're not really, they're dependent on the host that they're on. They can't really be host independent in terms of operating system. For example, you can't have a Windows container on a Linux host. Whereas with a virtual machine, of course, you can have like a Linux virtual machine on a Windows host and vice versa. So what you're seeing a lot of in the container space are you're seeing companies that are developing containers like Docker that are actually run on a lightweight virtual machine. So Docker actually runs on a virtual machine. Docker uses the Microsoft HyperV Hypervisor and runs on a lightweight virtual machine to do its job. So they are very similar, but there are some differences in terms of how they do what they do and what they are exactly. So I did some more research on that for you all just to let you all know what we have on that. And I saw Jorge say hi to the chat while I was on my Docker and Hypervisor rant. So hi, Jorge. So now on to what we're going to talk about this week, and that's our Chapter 2 objectives here. We're going to describe we're going to get more into hypervisors and what hypervisors are, which a lot of this stuff you kind of got a little inkling of from your Module 1 material. We're going to talk a little bit more about a lot of that stuff today. So we're going to describe a hypervisor, what a hypervisor does, where hypervisors came from, an interesting tidbit about how they got the name hypervisor. I got that for you today. And I want to talk about the difference between Type 1 and Type 2 hypervisors, the two roles of a hypervisor, and we're going to look at a few different brands of hypervisors and the commercial market of hypervisors, which kind of lends itself to the assignment that you all did last week as your lab. So a lot of that's probably old news for you all. So, as we talked about last week, hypervisors, as we know them now, started out as virtual machine monitors. You remember that they developed a need for virtual machines way back in the 50s, 60s, the early mainframe computing days, when they started building operating systems. For the purpose of trying to do some sandboxing for rapid and repeated testing. So the virtual machine monitors of the old days gave rise to the hypervisors of today. So when we're looking at hypervisors, one of the things that we have to consider is, well, what is a hypervisor? And that's what we have here on your screen now. So it's software that abstracts hardware resources from a virtual machine, and we mentioned that last week. So we're taking the physical hardware, taking it from something physical, abstracting it into something logical, so that we can run multiple different types of operations with it. So we need our hypervisor then to manage all of the interactions between the virtual machine and the hardware resources. Because the hardware resources that the virtual machines are using are virtualized. They're based on real physical hardware that the host has, but it's being abstracted into something logical, so it's virtualized. So we need another layer in there that allows us to manage those resources. And we have two different types of hypervisors that we use. One can run directly on hardware, or we can use a hypervisor that is an application on an operating system. And these are type 1 hypervisors and type 2 hypervisors respectively. And we'll talk more about the different types of hypervisors as we go along today. And as we've said, this is not a new concept. The hypervisor or the virtual machine monitor, it's not a new concept. It's been around for 60, 70 years. But in the last 20 years especially, we've seen it kind of boom in terms of commercial use. So we're really getting out there in terms of what we're doing with hypervisors. So what is my next slide? Okay, I got a little bit more before I get to my next slide. One of the questions that you might ask yourself is why a hypervisor? We've talked about what is a hypervisor here, but one of the questions that we might want to ask ourselves is why a hypervisor? Because we said, that it's software that abstracts hardware resources. Well, why did we really have that problem in the first place? The problem was that, we had engineers that were trying to solve the problem of resource allocation when they were trying to utilize memory that was not normally accessible. So the resources and the memory that the hypervisor gives us access to was not typically accessible by the machine or by software. We had, it's stuff that's reserved for our operating system, stuff that's reserved for different processes. And just as a little tidbit to kind of take with you as to why we call it a hypervisor, because it's kind of a funny name, hypervisor. It sounds like something from some kind of sci-fi novel. But in the early days, operating systems were called supervisors. So with the invention of hypervisors or virtual machine monitors, we actually had something that could supersede a supervisor. So the next level up from a supervisor is a hypervisor. So that's where that naming scheme comes into play. That's where we get the funny name of hypervisor from the days when operating systems were called supervisors and the virtual machine monitor could supersede a supervisor. So type 1 hypervisor. So a type 1 hypervisor can run directly on hardware with no operating system beneath it. So what this means is that there's no intervening layer between the hardware and the hypervisor. That gives us direct communication with the resources that the host has. We also call this a bare metal hypervisor. You can hear Type 1 hypervisor or bare metal hypervisor kind of used interchangeably. So a Type 1 hypervisor is more secure because guest operations are handed off. A guest cannot impact the hypervisor at all. So we have the guest OS on the virtual machine. All that's done on a handoff. That's completely sandboxed. A VM can only damage itself on a Type 1 hypervisor. A Type 1 hypervisor is also more available and offers better performance. It requires less processing overhead. So it requires less processing overhead to have a Type 1 hypervisor. Because of that direct connection between the hypervisor and the physical server, there's no intermediate layer there that it has to pass through for any kind of additional processing. Since it requires less processing overhead, that means you can have more machines per host on a Type 1 hypervisor. Because it's more efficient with the resources that are available, thanks to the reduced amount of processing, since there is no OS beneath the hypervisor here. So that's a Type 1 hypervisor. But that's not the type of hypervisor that we're going to be using mostly in class. The type of hypervisor that we're going to be using mostly in class is a Type 2 hypervisor. So the hypervisors that we're using in class is a Type 2 hypervisor. So a Type 2 hypervisor runs on top of an operating system. Now, one of the benefits of running on top of an operating system is that it's going to leverage the operating system drivers. This allows for the virtual machines that are built upon a Type 2 hypervisor to be easier to set up, because the configuration is handled by the operating system with those operating system drivers. And this was actually the quickest path to market. Like, this was the very first type of commercial hypervisor developed, was a Type 2 hypervisor. It was the easiest for people to develop and get out there quick and easy. The very first commercial VMware x86 hypervisors were the very first hypervisors running on an x86 system were developed by VMware. They were Type 2 hypervisors. Now, they're not as efficient as Type 1 hypervisors because they do have that extra layer between the physical hardware and the hypervisor. So there's that additional step of processing between everything that's going on. Now, what these are most often used for is desktop development and testing. And this is what I use a lot of my personal virtual machines for. You know, I have a virtual machine that's set up for Python development. I have a virtual machine that's a WordPress server that I use for WordPress development. And these are all virtual machines that are set up on a Type 2 hypervisor that, you know, were easy to set up using my host device's resources. and easy to use. And again, you know, just to be clear, the hypervisors that we're using in class are type 2 hypervisors. So VirtualBox, VMware Workstation, these are type 2 hypervisors. So let's talk a little bit more about abstracting hardware. So when you're on a guest operating system, on a virtual machine, what you're seeing is a virtual resource. So it's not the physical resource. It's a virtualized version of the physical resource. So you can kind of think about it in terms of if you've ever used the NetLabs system here at Cleveland Community College. You can think about it along those lines. There are real hardware resources that are attached to that system, but the environment Hey, Jonathan. That's potentially a really good question. Can you expand on that just a little bit more so I know what you mean? Like, do you mean, like, why not just have a server? So there are certain things that work better in a dedicated environment. One of the things that I can think of right offhand would be one of the best examples that I can think of right offhand is having a WordPress server. So you can virtualizing a WordPress server. Is way easier and cheaper for development purposes than it would be to actually have a server and doing development on that server. So I could take and virtualize a LAMP stack and install WordPress on it and do all my WordPress development on my own resources without having to set up a separate environment for WordPress. And then I can develop WordPress websites that way. So then you're not paying a server cost and you kind of have more control over your environment as far as all that goes. You might prefer to have a server. There is the point that the server is probably virtualized. Like if you're using Amazon Web Services, those are oftentimes, those are virtualized web servers unless you're, paying for a dedicated server. But there's also the fact that, you just like having your development kind of sandboxed and to where you can kind of play with it and kind of do your own thing. So, I mean, you very well could just, like to have a development environment. If you had a computer and you just wanted to install all the compilers and executables onto that one computer, I mean, that's a possibility. But I think the WordPress server is probably the best example for a good reason why you'd want to have something that was segmented on a virtual machine from a development standpoint. And then when it comes to virtualizing resources at the enterprise level, looking at something like AWS, I mean, those are all virtualized servers. So it's one big server resource where we're taking and segmenting a bunch of servers off of one big server resource. So there's even more applications at the enterprise level. But in general, this class more focuses on desktop virtualization, since what we're doing is mostly type 2 hypervisor type stuff. Because oftentimes when you're dealing with virtual servers in that regard, like AWS, you're dealing with bare metal hypervisors to be able to do your job there. But I mean, I guess to each their own. But does that sort of answer your question? Sure. Sure. Yeah. For desktop virtualization in general, there's a lot of it that's just kind of keeping things clean. And it's my big example is the WordPress development thing. I can create a bunch of different types of servers. So I can have a WordPress, I can have a LAMP stack, and I can have a Plone stack, or a mean stack, and a MERN stack. That's all virtualized. But yeah, you're right. For general personal use, there's not a ton of things that you'd virtualize. But it's also more of a introductory class, so we're just kind of getting our feet wet. Yeah. Cool. So let's see, where were we? Abstracting hardware. So again, the guests are seeing virtual resources, right? So there's real resources tied to it, but the resources are virtualized and put into an abstract, kind of logical sense. Like there's a theoretical RAM that you have in a virtual machine. It's tied to real RAM and real processing power that you have on your host. But again, your hypervisor is abstracting it. So your hypervisor is only presenting your guest or your virtual machine with a fraction of the host's available physical resources. And as you get into making a virtual machine in this first module, you'll kind of see how that works. You're not going to allocate all of your host's resources to your virtual machine, just because, that's kind of silly. If you need to allocate all of your host's resources to the virtual machine, you just kind of need to make it its own thing. And then you have your hypervisor managing the resource input-output and load balancing the workload. So it's kind of making sure that it's all doing all the work's getting done, everything that needs to be processed, in terms of that whole information cycle where we take data and turn it into information. Control unit, processing in the processor, arithmetic logic unit in the processor, doing all the processor things in terms of how all that works. Your hypervisor is kind of acting as the conductor to kind of make sure that all the workload happens. So let's talk about a few different products, just to make you aware of them, and then we'll go ahead and wrap things up. So VMware ESXi. So it's the first commercially available hypervisor, which we already mentioned. It was Type 2 hypervisor, developed in 1998 as x86. And VMware is really still the market leader in user share for for hypervisors and virtual machines. And they have the most users. They've been around the longest, so it's understandable that they're the market leader and doing the most to make the most happen. So the architecture is not tied to a specific operating system. OS independent. And you'll actually, as we go along, after your midterm, we'll actually be using some VMware products. Either you got an email or you didn't get an email, one or the other, which is a kind of an odd thing to say. But you do have a student VMware account. Once you get into there, get into the module where we start using VMware products, I'll have some more information for you about how to access the VMware products for students. You'll just want to reset your password, and then you can download what you need, and everything should be easy and good to go. But we don't have to worry about that quite yet. We don't have to worry about that for another few weeks, so we can be patient on that. There's also Microsoft Hyper-V, which is what I mentioned that Docker runs on top of earlier. So the Microsoft Hyper-V hypervisor product was first released in 2008, but we could get virtualization through a Microsoft product through the Microsoft Virtual Server a few years earlier. It's similar in architecture to Xen, which is on the next slide. But device drivers are part of the parent partition. So when you get into making your VirtualBox VM, you'll learn a little bit more about building that partition and working with the virtual machine. And then the parent partition for the Microsoft Hyper-V, of course, is based on Microsoft Windows because it's a Microsoft product. But yeah, and you can kind of see that virtual machine architecture there. Xen began as a Cambridge University research project. So it was first released in 2002 as an open source project. So it's open source, which means that there have been other projects that have been made off of this, and we'll see that on the next slide, that there are other projects that have been made off of the Xen hypervisor. But some of you might have talked about the Xen hypervisor or related hypervisors to the Xen hypervisor in your lab report from Module 1. So the core has been used in a number of vendors. The Citrix hypervisor has Xen in it. The Oracle hypervisor has Xen as a part of it. So it's primarily based around Linux, the Linux infrastructure. So I think we got like 2 more slides, so let's go ahead and power through those. Other solutions. So the Red Hat KVM was originally based on the open source Zen, but now it's kernel based. KVM, kernel virtual machines. Oracle. The Oracle virtual machines are Zen based. Then we have Amazon and Google. As I mentioned, AWS makes extensive use of virtualization through their virtual servers and all that kind of fun stuff. And the Google Cloud makes extensive use of virtualization. But all of the hypervisor backend virtual machine stuff is hidden from you. All that you get are the benefits of all of their hard work that has gone into making the hypervisors and the virtual machines and making everything work. So there are, as you all know, that now that you've researched a lot of products and things of that nature, many other commercial and free solutions are available, and there's a lot of stuff that's going around out there every single day. It's like I mentioned earlier. Within the past 20 years, this has really been a booming field, especially with the growth of cloud. The more cloud grows, the more we have a need for hypervisors and virtual machines. So we see new solutions coming in that regard all the time as well. So lots of stuff there. So in summary, we'll just run this down and we'll call it a day. We've gone a little past 30 minutes, so that's about where I want to sit for these online classes, so that's pretty good. A hypervisor is software that allows multiple workloads to simultaneously run on the same hardware. So it's that layer between the virtualized hardware for a type 1 hypervisor or the operating system and virtualized hardware between the hardware for a type 1 hypervisor or for a type 2 hypervisor between the operating system / hardware and the virtual machines. Type 1 hypervisors run directly on server hardware, while Type 2 hypervisors run on an operating system. For this class, since we're doing desktop virtualization, because that's really what you all have access to, because it'd really be hard to do much else. We're using Type 2 hypervisors. Hypervisors abstract the hardware, take something physical, turn it into something logical. From the VMs they support, and load balance the utilization of those resources. And there's all sorts of stuff happening in the virtualization market. VMware, Microsoft, Citrix, Oracle, which VirtualBox is an Oracle product, which is what we're using right now. And tons of others, some of which that are proprietary, like Amazon's AWS and the Google Cloud. All sorts of fun stuff. So that's the end. That's all I have for you for this week. Thank you to those of you who came. For those of you who weren't able to attend live this week, I hope you are able to attend live next week. If you have any questions, you can let me know via email, or also I'm going to turn the music back on and answer a few questions in chat here at the end. If you have any burning questions right now. But again, thank you all for coming, and we'll see you next time.